Okay, solving some logarithmic equations without using a calculator. We're going to be utilizing the definition of logarithm. This allows us to switch between logarithmic form and exponential form, as well as the one-to-one property of exponential functions. So what this says is if we have the exact same base on both sides and nothing else on that side, what we're allowed to do is drop these bases and set the exponents equal to one another. So jumping right in here, let's start out with y equals log base 3 of 1/27. So the first thing to note is we're in logarithmic form. Let's switch over to exponential form. So in exponential form, this is going to look like 3 raised to the y power equals 1/27. All right, my next goal is to get to the place where we can use the one-to-one property and drop the bases by having the exact same base on both sides. To do this, it's going to be handy if we rewrite. I would aim for 3 as my common base on both sides because it's smaller of the integer values and we need it to be positive as well. So the 1/27th, I don't really like that. Let's work on rewriting that. Maybe we can see 3 to a power on that side. So 27 can be rewritten as 3 times 3 times 3, or 3 cubed. The next thing I would probably do is go ahead and rewrite this. I don't want the 3 cubed in the denominator. I would like to move that up to the numerator. So using one of our exponent rules, we can rewrite that with a negative exponent and move this 3 cubed up to the numerator. Now we're in the position we have the exact same base on both sides. We're allowed to drop these 3's from the bases and set the exponents equal to one another based on that one-to-one property of exponential functions. So we've solved down and we have y equals -3. All right, let's take a look at log base 16 of 4. You may notice on this one that we have a logarithm, but it's not an equation like the definition of logarithm requires. So then the first thing I may do on this is go ahead and set it equal to some dummy variable. I'm going to utilize y, although you could pick whatever letter you want to solve for over on the right-hand side. Okay, now that we're in we have an equation that's written as a logarithmic equation, let's switch this over to exponential format. So this will be 16 raised to the y power equals 4. From here, what I would probably do is aim to get a common base on both sides, and I would probably aim for 4 because it's the smaller of these integers. So if I want to rewrite 16 as 4 to a power, I know that 4 times 4, or 4 squared, is the same thing as 16, but because 16 was raised to the y power, whatever I replace 16 with also has to be raised to the y power. From here, let's go ahead and combine these exponents together. We would have to multiply these exponents to combine them together, but we really want 4 just raised to a power on both sides. Now, it may be difficult to see, but when it's just 4, that's an automatically known it's 4 raised to the first power, or one copy of 4 over on this side. All right. Next, we have the exact same base on both sides. We're allowed to use this one-to-one property of exponential functions, which says you're allowed to drop these bases and set the exponents equal to one another. From here, we still haven't solved for y on one side by itself, but a pretty quick divide both sides by 2 will isolate the y on one side all by itself. 2 more quick examples of this. All right, let's look at y equals log base 2 of 1/32. So exponential form, we have 2 raised to the y power is 1/32. This is pretty similar to the one right above it, where what I'd probably want to do is rewrite it so I can see a 2 raised to a power on both sides. So the first thing I would do is rewrite that 32. Let me see, that's 2, 4, 8, 16, 32, and that's 2 raised to the 5th power. From here, we can also rewrite it, move it up to the numerator by saying 2 to the -5th power is equivalent to 1/2 to the +5th power. So we're at the point where we have 2 to the y is 2 to the -5th. We're allowed to drop those bases, set the exponents equal, and we end up with y equals -5. One last problem here. Let's take a look at log base 49 of x equals 1/2. So the first thing I would do on this is we're in logarithmic form. Let's switch this over, convert this to exponential form. So in this case, we have 49 is our base, is going to be raised to the 1/2 power, would equal x. All right, so in solving for x in this case, 49 raised to the 1/2 power, that's equivalent to the square root of 49. Or with a little bit of simplifying down, we're going to get x equals 7. So a little bit different as far as solving this one down, but kind of starts out the same way that you want to use the definition of logarithm to go from logarithm to exponential form, and then simplify down what you get. In this case, we didn't need the same base on both sides because that's not quite how the formatting worked like these previous ones did, but kind of starts out the same way. So just take your time as you're working on these, get these formulas down. They're very handy to know and not to have to look up each time. Just practice them, you'll get them down. Good luck.